It's tomorrow, if I'm not mistaken. Therefore, um, I will be able to assign you the assignment, the tutorial, what you need to do, and by tomorrow we can discuss it. Um, the thing is, ask everyone. I will not ask all the questions to be answered. I will select only a few questions for our discussion during the tutorial session. And the other question, you may wish to do it on your own, and if you need clarification regarding with the answer, you can ask me. Okay, so this is the second time we're having class. I mean, we had the discrete maths in the first semester, so this is your third semester, which is a long semester, and therefore I will be meeting you guys for 14 weeks, and I hope good performance in your result for this course, because each of you carries about 33% uh, in terms of the passing rate of this class, since there's only 3 of you. Right. As what is being displayed now, the name of course is Probability and Statistics, and the course code is BAMS 1613. Basically, this subject is more relating to statistics, in such that you're going to look at the definition of statistics. What is it about? Uh, the calculation of measures of central tendency, which basically it's about mean, median, and mode. You will also look into measures of dispersion, that is involving quartiles and standard deviation. And then we also look at the topic on probability, as what you can see here, probability, where my cursor is at the moment. Basic probability distribution, which is, I hope you all still remember, if you have taken additional maths, it's concerning normal distribution, binomial distribution, and Poisson distribution. Is it both of you? Did you cover additional maths during high school?
Uh, I think never heard of the Poisson.
Poisson, yeah, Poisson. Perhaps in high school you did not. Yeah, yeah. Now I remember. Um, but binomial and normal you did, yeah.
Hmm, I
Okay,
think yeah, I forget right.
but never mind. We'll cover it as from the basic. And then after that we're going to do sampling. Um, Not so much on the sampling though, but more on the estimation of parameters, where we're going to do what we call as the estimation in terms of confidence interval. Yeah. And then we're going to do hypothesis testing. These are new basically. Confidence interval, hypothesis testing, new in such that you have not learned it in high school. And also linear regression and correlation. So basically, the one I'm going to highlight here, as you can see here, are topics that you have not learned in high school. I can't really remember now whether you guys are fresh from high school straight away to your, oh no, yeah, now I remember, you were in a different institution, yes or not, for your diploma, then you joined for your degree, correct?
Oh yeah.
Okay, so I don't know whether you guys have learned all these topics that I've highlighted there: estimation of parameters, confidence interval, hypothesis testing, and the linear regression and correlation. Have
Uh,
you covered that before?
Miss forgot to
Mm?
record.
Oh, not yet, because this is just
Oh,
the introduction of the course, so I'm not recording it yet. I only record when we start the main lectures. But in the main lectures, I prepared slide that shows all this information. Also, I just want to ask whether have you learned these topics before previously in your previous place of study?
If me, no.
How about you, Calvin?
I don't think don't know.
Huh?
No, I think.
I see. Did you do any statistical paper in your diploma? I think you did, kan, for diploma level.
I did foundation, not diploma.
Oh, you did foundation. Yeah, I forgot already. After the second semester. Anyhow, yeah, what I also wanted to focus on, I did prepare in the slides also, are the three course learning outcomes. Yeah, so we have three here: CLO1, CLO2, and CLO3. Yeah, course learning outcomes, which I will mention in the main slide later on also. Yeah. So the next thing I want to show is the course plan. So this is the course plan which I just downloaded earlier this morning, and you can see we are in week 1. You have a lecture and tutorial. Also, we have the session. Yeah. So this week, even though it's week 1, we still have tutorials. Yeah. Some subjects they don't have tutorial in week 1. Yeah, so these are the layout for all the 14 weeks. As you can see, we have all these topics listed here accordingly. So this particular PDF, Form B, I will share in the Google Classroom later on so that you will be able to keep track whether um, we are, how do you say that? According to the weekly plan for the conduct of the lectures. Yeah. So this one I will share later on. Yeah. So I also have shared with you guys the lectures for chapter 1, the lecture notes for chapter 1. And of course, you have chapter 2 and so forth also. Yeah. So I did mention in the Google Classroom for you to print out the notes, but it's up to you again. Perhaps you have your own mode of learning now, considering this is not your first semester, this is your third semester already, and you have been doing online for quite a while now, so you are familiar with what you need to do. So some of you might not want to print the notes. It's okay. You might have the facilities to directly write on your PDF digitally. So that should be okay also. But up to you, yeah, whichever method that you find comfortable. But just to share with everyone, the difference with this mathematical statistical paper that we're going to do this semester is different in such that in discrete maths, it is more on looking at the structures mathematically, meaning there's not much writing needs to be done, not much calculation needed to be done in the discrete mathematics paper. But this time, in the probability and statistics, it's different in such that a calculator is your best friend because there's a lot of numbers that you have to calculate. You may need graph paper, but I haven't received any clarification in terms of you needed to draw graph during the assessment. So let me get information on that first. At the moment, you don't need to rush and go buy graph paper, yeah. But of course, what I'm going to share with you today would be looking at a bit of graph paper, a graph kind of structure, and some of the tutorial question would you would need to solve it with the graph, graph paper in hand. Yeah, so that's the difference mainly in the subject we're going to learn today. It's more on calculation. It's not more on, well, you need to understand, of course, but there's a lot more calculation involved, and you need a calculator, that is, because some numbers can get pretty much big values. Okay, so I think that's it. Just a brief introduction about the PDF file, which I hope all of you have access of it. Okay, so any questions so far, class?
No.
Yeah, clear. So if you have any question, just like in my previous lecture, I would appreciate that you ask anything that you're unclear of. So today our class is from 9 until 11. Of course, as always, I will give breaks. So let me prepare to show the slides first, and then I'll join you in a bit. Give me about 2 minutes, okay?
Okay.
Okay, good morning, everyone. Today is 18th of January 2021, and it's the first week one, and we're going to start with the chapter 1. Yeah, but before I start on explaining about chapter 1, let me have a brief introduction about BAMS 1613, which the subject name is Probability and Statistics. So today's semester 3 for the academic session 2020 to 2021, and we have 14 weeks to cover this syllabus. So I hope everybody is ready. Yes?
Yeah.
Okay. So I've explained about um, the topics earlier, but let me go through them again. So we have generally about 7 topics altogether, only 7. And as you can see, these are the topics. Yeah. Just to highlight again to everyone that from chapter 1, yeah, to chapter 4 are topics that you have covered during high school. It's just that perhaps the question would be slightly different manner being asked to students. But all of the topics from introduction to statistics, descriptive statistics, probability and probability distribution are all topics that you have covered during high school. So perhaps the 3 chapters, estimation and confidence interval, hypothesis testing, and regression and correlation, the last 3 topics are new to everyone. I would like to add also that the 3 last topics are very important uh, to understand if you have the intention to do further studies uh, that will aid in your research paper. Yeah, say you want to do your master's or your PhD. Well, of course, what I cover is more on the basic introduction to all these topics, but it surely definitely will help you when you are preparing for further studies later on. Yeah, but of course, here are just the brief introduction about these topics that are mainly used by researchers in their research paper. Yeah. So the course learning outcomes, we have three course learning outcomes. The first one is that by the end of the semesters, students should be able to illustrate data both graphically and numerically. This is based on your prior knowledge during high school and even in your diploma or foundation studies, that you should be able to draw um, datas presented in a graph. Yeah, so that is the first outcomes, learning outcomes that is intended for you after you complete this course. Secondly, you should be able to solve problems involving probability theory, probability distribution. This is where I mentioned about normal distribution, binomial distribution, and Poisson distribution. And of course, to be able to know what is correlation and regression and solve problems as well. And we also have the third course learning outcomes. We are to analyze statistical inference techniques, which relate to confidence intervals and hypothesis testing. Yeah, just to let everyone know as well that all the topics that we cover today are similar to the topics that is being covered in the diploma course as well. They also cover a subject, same name, probability and statistics. So since all of you are doing your degree, and I think the administration has checked that you have not covered this syllabus, this topic before during your diploma and your foundation studies. That's why all of you are not exempted from this topic. You have to do this topic for this semester. Okay, so these are the learning outcomes that is intended for you to be able to master by the end of the semester. Okay, right. So moving on. The next part is I'm going to talk about your assessment, and we have a coursework which is 50%, and we also have the final examination. Yeah, so the coursework 50% consists of tests which has 6 questions, and it will cover from chapter 1 to chapter 4, and that would be issued in week 8 or week 9 depending on our progress. And then we also have assignment, which consists of 7 questions, and that would cover chapter 2 to 5 and issued around week 10 or week 11. So all this, considering that we're still under MCO, will definitely be done online. And we have experienced that when we did the discrete mathematics subject in first semester. Yeah, so it will be conducted similarly. Yeah. Okay, and the final examination, which is expected early May 2021, would contribute the 50% in your final grade. So coursework 50%, examination also 50%. Okay, any question for now?
Miss,
Yes.
the about the graphic tab. graph
Graph
paper.
paper, yes.
Yeah. Need to buy or what?
Oh, don't yet. Do not buy yet.
Oh,
Until I get confirmation from the course leader, the
okay.
course coordinator, and I will let you know.
Okay.
Yeah, because this time the MCO is not as bad as the first one. MCO 2.0, we can go to the shops and get the materials that we need, right? Like last time, a lot of shops are closed. This time, I notice it's much better. So perhaps graph paper would be needed. Yeah, because last time shops were closed, so that was why graph paper was not required then. But this time, uh, the shops are more accessible, so we might need to use it. Okay, but I dare not to confirm now. Later on, I will confirm. Remind me again if I do forget. Okay, but I will make it as a priority to us. Okay. All right. So chapter one. I'm going to start chapter one now. Yeah. Any question before I start? That one was just a brief introduction um, to the subject. I hope you are clear what is your aim. And of course, I hope everybody's aim is to get the highest grade possible, as what I wish all of you to get also. Right. So if there's no question, I'm going to start with chapter one, the introduction to statistics. So mainly, chapter one is just an introduction part. Yeah, it's not much calculation involved. It's just helping you to recall back about what statistic is about. So first of all, we're going to start with the definition of statistics. And the word statistics is basically, it has three meanings. First of all, it refers to numerical facts. That means data are given to us in numbers, in values, in numbers values. And that's the first meaning. Yeah, statistic refers to numerical facts. And then statistics also refers to the field or discipline of study, in such that the process involve five process that we have to collect the data, analyze it, then we present the data graphically, and from there you should be able to interpret the data either from the graph or from the data that you have analyzed, and from there to help make decisions. So that is why statistics are used in almost every area in the industry. Statistics is used in education, statistics is used in politics, statistics is used in medical. Yeah, just like what you see every day, we get a statistical result of the number of cases of COVID that we receive daily. Yeah, and from that statistical report, it helps the person who's handling those report to make decisions. It's used, statistics is used in business, whereby business owner, they use the statistics to help them make decisions. Yeah. And the third definition of statistic is categorized to the number three here, whereby it refers to particular quantity that has been calculated from a sample data, that is mean, median, and mode. Yeah, and variance and standard deviation. So this is what we cover in chapter 2. But of course, statistic doesn't stay on mean, median, mode, variance, and standard deviation only. No. As what you see in all the 7 topics that I've shared to you just now. So those are the overall area of statistical topics that we're going to cover. But in all honesty, everyone, there are so many other topics that is not covered in our syllabus, like the t-tests, like the ANOVA, the multivariate analysis. There's a lot more statistical calculation that we do not cover, and there's so many out there. And one thing about this topic is that this subject, the syllabus, we do not use any of the statistical tools. Yeah, um, like the SSPN statistical tools that is being used in most statistical evaluation. Yeah, because more on the calculation in what we're doing in this course. So there are three branches of statistics. We have descriptive statistics, inductive statistics, or rather called inferential, and probability theory. Now, the descriptive is more on what we're going to cover in chapter 2, whereby we describe the data using graphs and tables, and we measure it using the central tendency method and measure of dispersion, just like mean, median mode, standard deviation. So we can say descriptive statistics is the most convenient and very easy to use because you have been exposed to all the topics of descriptive statistics since high school. Yeah. Then when we go to inductive statistics, more into inferential, these statistical calculation are more into helping us to make decisions or make prediction or making inferences, and of course at the end to have a conclusion about an overall population based on the samples. And of course these I will talk more about what is the difference between population and sample. Yeah. We will tend to do the calculation of the statistics based on samples only, and from that sample we can deduce the population. Yeah, I'll talk about this further as we go along in the introduction part. Yeah, and then we have probability theory. Now this is where we are looking at the measurement in terms of likelihood, the chances of something to happen. So I'm sure all of you have learned about probability in your previous educational area. Yeah, and in such that we are going to look at probability value. Yeah, and because of that, the probability theory, it has links between descriptive and inferential statistics. That means between these two statistics, probability theory is a mixture of it. Yeah, so in a way, what we're going to do in this course, in this semester, is all these three branches of statistics. And as what I've mentioned, we only cover just a few of the statistical tools, not all. Yeah, because if we cover all, it's not enough time anyhow. Yeah, so some topics we do not cover, like chi-squared, we do not cover. Um, t-test we do not cover, ANOVA we do not cover. We only cover just the main topics that I've shown to you earlier. So I mentioned about population and sample, right? So here, what we have is basically, in order for us to be able to draw a conclusion about the population, we are only going to study the sample. So that means from this diagram, we collect small samples, like we have this one sample here, another sample, another sample, another sample. And from all this sample, we're going to combine it, and statistically, of course, and then we draw conclusion based on the large population. So I hope you can visualize that, like the area for Sabah. Yeah, Sabah is a population, and we take like Penampang, Papar, Kota Kinabalu, Beaufort, Sandakan, Lahad Datu. All those are small samples that we take from different districts, and from that sample we can draw a conclusion about the population of Sabah. Yeah, so that's the main idea. You have to understand population is the overall picture. Sample is just a small sample taken from each district of Sabah, and from that sample we can draw, or we can have a conclusion about the population. Yeah, you can also look at it in a bigger picture, of course, like in terms of the earth, the whole world, and we can take samples from each countries. Like we take some samples from Australia, some samples from England, some samples from German, and that samples are taken to have a conclusion about the world. Yeah, we can have a very good example now, like the COVID cases that is happening all over the world. Yeah, do you understand the idea of it between population and sample?
Oh, yeah.
Yes? Okay, that's good. How about you, Calvin? Okay?
Yeah.
Okay, good. Yeah. So please, again, do not feel shy if you have any questions or areas that you don't understand in terms of my explanation. Let me know so that I can explain it further and be more, able to explain to you clearer, of course. Yeah. Right. So this is an example one. If you look at the notes that I've shared with you, um, it's all there. So it's just a matter of discussion. So what I have in here is the first example, and it's about, say, we want to study the height of the students from TAR UC. So population is involving all students from TAR UC, and our sample will only be 500 students from TAR UC. So you see the difference between population and sample. Okay, and the parameter here is a numerical value summarizing all the data of an entire population. So we don't know what is the numerical value at the moment. Yeah. Um, well, there's so many to choose from, and it's the decision of the person who are doing the how do you say, doing the survey or doing the investigation will decide what kind of exact parameter that you would like to use. Okay. Now we have another example. Now this is about student interested in finding out something about the average ringgit value of cars owned by the staff of TAR UC, TAR College or TAR UC. So the population is basically the collection of all cars owned by staff at TAR UC, and the sample is any subset of that population. So you can take the sample, maybe you want to take from staff in the maths department, staff from the engineering population. Yeah, you can take the samples from there. Yeah, so in this case, as you can see here, for example, the cars owned by members of the mathematics and statistics department in a sample. So you can take the sample from that. Or you can take a sample from the engineering staff, or you can take sample from the accounting staff. So basically, in this second example, it's just I hope you can understand what is the difference between population and sample. Population is all. Sample is only a subset or some part of a similar category. Yeah. And of course, the variable here is about the ringgit value of each individual car. Okay. Right. So continuation of example 2, say that the set of values corresponding to the sample that we obtain could be the value of the car is 65,000, 42,000, or 1,000, 120,000, and so forth. So therefore, the parameter is the average value of all cars in the population. That's the parameter that we're going to focus on. Since it is about average, therefore, the statistic is, we call it as the average. Okay, is it the same on the notes? Just in case I mistype, I hope I didn't mistype it. Let me double check. Huh? Okay, that's correct. Right, moving on. So we also have example 3. This is about the admission office. They want to estimate the cost of textbooks for students at our college. And we say X as the variable, yeah, of the total cost of all textbook purchased by a student this semester. And what is the plan is to randomly identify 50 students and obtain their total textbook costs. And we use the average cost for 50 students to estimate the average cost for all students. So here we have 4 questions. First is to describe the parameters. What is the population? What is the sample? And then describe the statistics. How would you use the 50 data collected to calculate the statistics? So for this example 3, yeah, the parameter is the average cost of textbooks for the semester per student for all the students. That would be our parameter, because that was the main discussion or the main area that we want to find out. The population would be all the students. You can see the word all students enrolled for this semester. And then what is the sample? Sample, of course, only the 50 students. And then the 50 data collected, we are going to use the average cost of textbook for the semester per student for the 50 students. Yeah. And how do you do that? Is to add all the 50 values and divide by the total of 50. So basically the last sentence here is just finding the average, just like what we have stated here. Yeah. Describe the statistics, which is to find the average cost. So you see here, class, this is a very simple example how we have done a statistical calculation concerning with finding the average. Yeah. As you can see in this example 3, what we did here is identifying what is the parameter, identifying what is the population, and identifying what is the sample from the scenario given to you, and then decide on what is the best statistics to calculate them. Yeah. So okay. So what I want to focus on here is that based on the example 3, I am not sure whether whether you'll be asked to do this, like, because this is very, how do you say, very wordy kind of example. So as you can see in the assessment that I shown to you earlier, that in the test, it covers chapter 1 to chapter 4, right? So it could be the chapter 1 will be asking you to do this. Like from a scenario given, you are to describe what is the parameter, and then to find out what is the population from the scenario given, and then decide what is the sample, and find out what is the best statistical method to find the solution. So expect this to be asked as question from chapter 1, yeah, in terms of your Tesla. But then again, it all depends, yeah. What kind of question, yeah, that will be asked in terms of chapter 1 for your test. Because if you look at the chapter 1, it's not involving any calculation whatsoever. It's more on theoretical introduction to statistics. Okay. So we go on to the types of variables. It's categorized into quantitative variable. Quantitative means it's numerical values, which we can see the value. And we also have qualitative or categorical variable. So just to explain to you what is the difference is that all these are variables, yeah, as what you see on the screen now. Like we can measure incomes of each family, for example. We can measure the height of students in a class. We can measure the sales in a week. We can calculate the number of accidents per month. So all these are considered variables. But what I have shown to you here are variables that is from the type of variables which we call it as quantitative variables. Yeah, because each one that you see here are we can calculate them. Yeah, unlike the qualitative, we can't. Yeah, so before I go to qualitative, let me explain to you about quantitative first. The quantitative are divided into two some more, which is discrete and continuous. What is the difference? For discrete data, it is concerning with values that are fixed. Fixed in a sense that there is no decimal places when you categorize the value. So they are considered as discrete. For example, the number of houses. You cannot say a house is 2.3 houses. That man owns 2.3 houses. It's impossible, isn't it? So that kind of data, houses, is considered as a discrete data. Yeah. Another example, people. You cannot say 5.7 people. It's impossible because people, houses, books, pens, cars, all these kind of data, it has no decimal places. It's a fixed one pen. You cannot say 1.5 pen, isn't it? So those kind of data are what we consider as discrete variables, discrete data. People, houses, pens, rooms, those are what we call as discrete. Unlike continuous data, these kind of data are the ones that involve with measurement most of the time, like the measurement of flour, the measurement of rice, the length of the table, the kilometers traveled, the height of a person. All these are continuous data because you cannot say a person is 167 centimeter exactly, because normally people will be 167.3, or even the measurement of tables. You cannot have exactly 100 centimeter. No, it will definitely has decimal places to it. So that's the main difference between discrete and continuous. Discrete are concerning with values that is a whole number. Continuous are values that are with decimal values. So remember this type of variables. You have quantitative variables, which are discrete and continuous. I hope you know the difference between them now. And we also have qualitative or categorical variables, are data that are, let me show you this slide first, which I already explained to you, yeah? Continuous cannot take exact values, and it can be given only within a certain range or measured to a certain degree of accuracy. Yeah. Example, height of students. Yeah, as what I mentioned here, 170.1 centimeter or even 178.1 centimeters. So these I've explained. I hope you understand that. Is that clear?
Yeah.
Okay. Whereas qualitative categorical variable are data that is collected on a qualitative variable, which you cannot label numerically. Yeah, like an example given to you here, the grade for BAMS 1613, the example of qualitative data, you can get A, B, C, or F, yes or not? Yeah. Um, that means there is no number assigned to it. There's no numerical value assigned to qualitative data, but we can categorize it. We can categorize that, okay, you're an A student, you're a B student, or you are a C student. Just like our blood, some person would have A blood, B blood, or O blood. Yes or not? You can categorize the blood, but you cannot put a numerical value to it. Just like cars, imported cars or local cars. Yeah, of course, now people tend to judge in terms of cars, in terms of the value of the cars. But if you just mention about cars, the brand of it, we cannot distinguish it numerically. We can distinguish it based on category only. Yeah, so that's the difference between quantitative data, which quantitative data you have discrete data and continuous data, and qualitative data is more categorical. Yeah, so that is basically what is important in chapter 1. Yeah, in summary, you need to know what is statistic is about. What are the 3 types of statistical calculation: descriptive, inferential, and probability. And then you need to know what is the difference between population and sample. Yeah, population is the bigger scenario, sample is just a small part of it. And then the type of variables, that is, you must know what is discrete, continuous, that is under quantitative data, and what is qualitative data. Yeah, so is that clear? Do you understand?
Oh yeah.
Yeah, no question?
Mostly describing only.
Yeah, chapter 1 is more on describing, more on the theoretical, more on the introduction of statistics, more on understanding what statistic is about. Well, you know statistics, you've learned it before, yes or no? It's just that now you guys are just, recalling back to what it is about. So I hope you guys understand. I'm giving everyone a break, 10 minutes break. Is that okay?
Oh, after this
Okay.
chapter 2.
Yeah, we're going to chapter 2 now.
Oh,
Yeah,
okay.
so 10 minutes break. We're going to prepare for chapter 2. I'll see you guys in 10 minutes time. Okay?
Okay.
Okay, see you guys. Okay, welcome back. I hope everybody is back. Yes, Noel and Kelvin.
Oh yeah.
Yeah.
Unfortunately, Sarah has not joined us yet. I don't know what is the reason. I hope he can join us later on. But if not, I have the recorded one here. So hopefully he can go through them. Yeah, chapter 2 is about descriptive statistics. Yeah, I'm not going to cover all, but as much as we can cover until 11 a.m. because our session today is until 11 a.m. And first of all, I'm going to talk about frequency distribution. Some parts of my slides here is not entirely the same as your notes, yeah, but it's rather much similar in terms of the examples, but maybe I add a bit here and there, which I hope you can understand this topic better, yeah. And if there is anything you're unsure of, do let me know so that I can clarify it. Okay, so actually the main part I want to talk about is the raw data, not the frequency distribution. The frequency distribution is basically the table that we arrange all the data into. Yeah, so in chapter 1 we look at the different types of data, yeah, like discrete data, continuous data. So when I say raw data here is in reference to data that has not been arranged, yeah, and it has not been organized, it has not been processed, it has not been ranked. It's simply a data that has been collected and it has not been organized in any form. And for everyone's information, the topic we're doing now under descriptive statistics, we are focusing more on quantitative data. Yeah, quantitative data. That means the data we have, it can either be discrete or continuous. We are not going to cover data that is qualitative. No. Yeah, only discrete or continuous data in reference to quantitative data. Okay, I hope that make sense to you. I hope you understand. If not, please let me know so that I can clarify it. So the process of collected the raw, after you have collected the raw data, is we need to organize the raw data, which whereby this is basically a process, and a process that we can summarize a very large and complicated set of data so that it becomes a more compact and easier to understand data. So that's why when you have collected the data, it is all non-organized, not processed, not ranked. But when we organize the data, the intention is to process it so that it can be summarized into a more understandable data. Okay. And one process which we call grouping is to help us so that we are able to organize the data. We call it as grouping. Okay. Which something you know already since you've learned it in high school. And therefore, when we do the grouping, we are actually constructing what we call as the frequency distribution of the raw data. So that's why I've written the frequency distribution up here. Basically, the raw data, once you collect it, of course, in our syllabus, we do not go and collect data lah. The data is already given to us in the form of a frequency distribution. It's already in the form of a table. We just need to evaluate the data. Okay, so this is one example of a frequency distribution. This is table 1. It's about the weights of 20 students in kilograms. So you can see all the data are collected, only 20 students, and all these are showing how much do they weigh. Yeah, so if you just look at this table 1 at a glance, it's very difficult for us to make any conclusion from it. It's very difficult for us to summarize any findings from the data collected. Okay, so this is simply a table. It has, in fact, it has not been placed in a frequency distribution yet. It's just a table showing us a raw data. Same thing with table number 2. You can see here, yeah. However, table number 1 is more in reference to quantitative raw data. Why do we say it's quantitative? It's because it's numerical. Each of the data that we collected are numerical. Now remember, it's about weights. So weights, definitely there would be decimal places. So in a way, when we're talking about weights, this data is under continuous data. Yeah, because weights are continuous data. Because weights normally has decimal places. Weights are under categorized as measurement kind of data. Yeah. So if you look at table number 2, this is qualitative data, because this is talking about the grades of AAMS 2613 of 20 students. Still 20 students, but look at the values, each of the data. It is grades, and the grades has no numerical value. So it's considered as qualitative raw data. So what we need to do, therefore, is to arrange the data into an array. Now, for quantitative data, you can see here quantitative data, we arrange the data either ascending or descending order of value. So it's possible either you arrange it ascending or descending, but of course we always do ascending order. Yeah, always do ascending order. Yeah, just to remind everyone. You can do descending, you'll still get the same value basically, but preferably do it ascending order. And when we do array, it's more suitable for organizing raw data if the data set is small, meaning it is less than 30. Yeah, if you have a small data, less than 30, then you can, in a way, do this. Yeah, for array. For example, say I have 10 workers. It shows the time in minutes for each of the workers to produce 1 unit of the item. Yeah, so what you can see here, I have array in ascending order. That means from the smallest 4 to the biggest value. 4 minutes is the time taken, the shortest time taken, or 9.5 minutes as the longest time taken. So this is an array in ascending order, or you could also have an array in descending order. That means from the biggest to the smallest. Yeah, so we can do array. Say you want to arrange the data from the smallest to the biggest. If your data is small, yeah, recommended here less than 30. But even if you have like 29 data, It's already a hassle to do the arrangement. So preferably be below 15 actually. Then you can do an array. Yeah, just like this. So this is concerning with creating an array for small kind of data. And like I said, you can arrange it in ascending order or descending order, but much preferably ascending order. Okay. So when we go to descriptive statistics for ungrouped data, basically it contains information of each member of the sample. Say we have 20 data in table 1 and table 2 in the previous slides that I've shown to you. Yeah. So from that particular data, we can get information which we call it as range. And the range is finding the largest and the smallest value. For example, the range, the calculation of it is equal to the largest value minus the smallest value. So if I have from table number 1, the largest value is 74, the smallest value is 60. So you just minus them. The largest value minus the smallest value, that gives us 14 kilogram. So that is the range. Yeah. So I'm sure you have read it somewhere. You have heard people say the range. That means the process of finding the range is looking at the data that you have, identifying the smallest value, identifying the biggest value, and just minus them, and that is the range. So an example, it can be used in a vegetable shop, for example. The range of selling the vegetables is from the highest is say 70 kilograms and the lowest is 50 kilograms. So the range is 20 because 70 minus 50, you get 20. So by getting the range, you have a very rough idea, yeah, what is the smallest and the biggest, how big the range in that particular shop. Yeah. So if you have a bigger range, then there's something going on. There's something fishy going on. But if you have a smaller range, that means it's comparable each day. Yeah. So this is the first statistical, simplest statistical calculation, which is called the range. You find the largest, you find the smallest, and just minus them. Yeah. So this one sometimes asked in the assessment also. So we go on to the frequency distribution. This is the process where we're going to organize the data now. Yeah. And remember, we have the data, the weights of 20 students in kilogram. And we're going to tabulate it into a frequency distribution. So in a way, frequency distribution, the definition to it is a tabular arrangement of data by classes, which together with the corresponding class frequency. So if you remember the data that we have, yeah, the data that we have in the earlier table, in the earlier slides that I've shown to you, we have 60 to 62, 63 to 63, 66 to 68, 69 to 71, and 72 to 74. That means it's classified into this category. So if I go back to the slides earlier, from table number 1, you can see the smallest one is 60, isn't it? And the biggest value is 74. Yeah. So we got the range from 74 minus 60. That's your range. But now we go into more detail in the construction of the frequency distribution. So from the value 60 to 60, is it 60 to 63 or 60 to 62? Which one is it, class? 60 to 63? 60 to 63 or 60 to 62?
62.
Yeah. So you can see from the table here, we have 60, 61, 62. What else? Only three, right? 60, 61, and 62, which falls in the first category. So I hope you are looking at the notes, because what I'm going to show you is the table here, and I'm sure you have the answer already in your notes, but I just want to show you. That's why the tally is 3, because as I've shown to you in the previous slide, there's only 3 values that is under 60 to 62. So here we have 3. Yeah. From 63 to 65, there's 4. 66 to 68, there's 5. 69 to 71, there's 6. And 72 to 74, there's 2. So basically from here, it's easier to see. It's easier to see now. Once we have constructed what we call as frequency distribution, it's clearly to us now that the weight from 69 to 71, you can see here, 69 to 71, is the highest. There are 6 students under this category. Yeah, even though the values are not much difference, like 66 to 68, there are 5 students. So generally, most of the students are between the weight 66 to 71 kg. Yeah, and of course, the first class are weights from 60 to 62, which consists of only 3 students. So the number of students here is basically the frequency. Okay, so that's how we categorize the raw data to become a frequency distribution table, just like what you've seen here. And from this frequency distribution table, we can get a lot of information, statistical information, that would help us to make decisions. Like information about the weights of students. Majority of the students from 66 to 71 kg. So once you have this kind of weight, say this school, this school, they want to order uniforms for the students, so they know what size to order. Yeah, generally because the students, the weight are on this category, they would know what are the size that they should basically order. So as compared to the table that we seen earlier, let me go back to the slide earlier, this one. You see, very hard for us to see any conclusion from this data because it's not a range, it's called a raw data. As compared to the data when it has been arranged in this manner, it's more clearly possible for us to derive a conclusion, isn't it? So collection of data is the first stage. And once you process it, analyze it, put it into a frequency distribution table, it's more possible for us to see the data clearly. Like 60 to 62, oh, there's only 3%. And we know the highest is from 69 to 71. I hope that is clear to everyone. Yes?
Yeah.
Okay, good. So this is just to show you the value tree where I got it from. So for group data, the data organized and summarized in the frequency distribution as shown is in table 3. The problem is when we do this, some of the original information is being ignored. Yeah. What does it mean? It's because even though we know from 60 to 62 there are 3 students, we don't know whether the 3 students, is it 60, all of them are 60, or all of them are 61, or all of them are 62. We don't know, isn't it? So that is what it meant here. Some original information are being ignored. One good thing though, non-overlapping. Yeah, that means the data, well, it can be a good thing or it can be a bad thing. Non-overlapping means the data are categorized into its own category, so there's no overlapping. So each values, they only belong to one and only one class. But what happens when you have 60 and then you got another person with 60, another person with 60? Of course, it doesn't overlap in terms of classes. Yeah. But in terms of the data, it could be repeated data and we're not able to identify that. Yeah. Right. So when we construct a frequency distribution, there are some basic components that you must know. There are 4 actually. The first one is what we call as the class interval. Now, the class interval is an interval that includes all values that falls into the 2 numbers. So remember the third class? The third class was covering 66 to 68, yes? So we have what we call as class limits, which referring to endpoints of each interval. So for example, here, third class interval is from 66 to 68. Lower class limit is the 66, which is the lower of the class interval. And the upper class limit is 68, which is the bigger value of the class interval. Okay, so this is important for you to know because I might use these terms as I go through the lectures. So remember, every class interval, in this example, I have 66 to 68. So this is the lower class limit. 66 is the lower class limit, and the upper class limit is 68. I hope that is clear, yeah? And please stop me if you're not sure. And then we have the second one, which is class boundaries. Now, this is pretty much interesting, okay? So you see, how do I explain it further? You see all the answers are already written here, like upper second class limit is 65.5, lower third class limit is 65.5. Therefore, the class boundary is between second and third is 65.5. So for this explanation, I would like to go back to the slides previously and explain to you guys. You see here, this is the data that I have. Yeah, 60 to 62 as the first category, 63 to 65 as the second category. So I'm focusing on 66 to 68, okay? Now you see here, we know 66 is the lower class limit, 68 is the upper class limit. But in terms of class boundaries, yeah, you can see 65, the class before it, and the class under discussion, 66, there is a gap. Yeah. Gap means 65 to 66. So the lower class boundary, we're talking about class boundary, yeah, we take the value in between 65 and 66. That means we are taking 65.5. That is our lower class boundary. And our upper class boundary is, you see 68 is the upper class limit. So the upper class boundary would be 68.5 because the next value is 69. So we take the in between 68 and 69. That's why we have 68.5. Is that clear? Any question?
Yeah, but the class frequency, why is it 3?
Why is it 3? This one?
Yeah.
Oh, remember when I was when we go back to the first table here, the class frequency is 3 because you have 61, 62, and 60. There's only 3 within that category, from 60 to 62.
Oh, okay.
Okay? So you have to count for each one lah. Like if I go back to the slides here, you can see if you go back to the table 1 just now, from 63 to 65, there are 4. 66 to 68, there are 5. 69 to 71, there are 6. And 72 to 74, there are 2.
Okay.
Is that clear? Yeah.
Okay.
And basically, if I go back, if I go forward, basically, I've already explained class interval. Class boundaries, you can see here. Yeah. Upper second class limit, 65.5. Yeah. So the lower class limit, lower third class limit is 65.5. So therefore, the class boundary between second and third is 65.5 plus. Yeah. So I didn't, let me go back here just in case you're not clear. You see, it's between here. This is the second. This is the third. So the second here is 65. The next one is 66. There is a gap. So the class boundary is 65.5 plus 65.5. So when there is a gap, you take the midpoint. Is that clear?
Yeah.
Sure. Kelvin, okay?
Yeah.
Yes, okay, good. I hope you guys understand. Because it's important, okay, as we go along with the topics in chapter 2, and chapter 2 is quite a big area in your assessment also. You need to get this correct, because if you get the values incorrect, it will affect the rest of your answer. Yeah. But of course, I will show you some other examples so that I hope you guys will understand it. Now, the class size or class width is in reference to the class size. Yeah, what is the width? And the class size is simply you minus the upper class boundary minus with the lower class boundary. Yeah, so 65.5 minus 62.5 equals to 3. Yeah, so was this the one you asked? Is it Noel? Let me go back here again. So that means here you see the class limit is 60, lower class limit, upper class limit is 62. But when we look here, we have 62 and 63, right? So the class boundary would be 62.5 to 65.5. Same thing here for 66 to 68. The lower class boundary is 65.5, and the upper class limit, upper class boundary is 68.5. So when we want to calculate the class size or the class width, you just minus 68.5 minus with 65.5. And that would give you the size 3. So if you do the same with the second category, 65.5 minus 62.5, it still gives you the 3. So that's why the size is always a 3. I go back here again. Is that clear?
Yeah.
Okay. So that's why you see here, get my pen. You can see here 65.5 to 62.5 is equal to the value of 3. And we have class mark, or also known as class midpoint. Now this is in reference to the midpoint between the class intervals. So say I'm focusing on 66 to 68. So what you do is you take the lower class limit, 66, you plus with 68, the upper class limit, and divide by 2, which will give you 67. You could also use the class boundaries. The class boundaries that we have identified earlier. You can also use it for each category and you still get the same value as 67. So either you use the class limit or you use, well, we call it class interval, yeah? Or you use the class boundaries, it still gives you the same answer, 67. Okay? So that's the class mark or class midpoint. All right? And always remember that the class mark is based on this formula, which is lower class limit plus with upper class limit and divide by 2. Just what I've explained here, I just highlighted it here. Because when you want to calculate the mean, you need to get the value of the class mark, the value of the x. Okay. Okay, moving on. So this is an example to help you to understand the class boundaries, class size, and class mark. So you can see here 11 to 20 as the class intervals, 21 to 30, 31 to 40, and so forth, right? So the class boundaries, you can see there is a gap, 20 to 21. So 11 here would start off from 10.5 to 20.5. So you can see here also 21 to 30 would be 20.5 to 30.5 and so forth. You understand?
Yeah.
Yes. Okay. Now the class size, you just minus. You can either use the class interval 20 minus 11, or you can use 20.5 minus 10.5. It will still give you, oh, if you use 20 minus 11, it won't give you the correct answer because it will tell you 9, isn't it? So yeah, this one you need to be careful. Let me rephrase my words just now. If you want to find the class size, especially when there is a gap in between the first category to the second category, better use the class boundaries because you don't want to get the wrong class size. So when you use the class boundaries, 20.5 minus 10.5, you get the correct answer, which is a 10. Okay? But in terms of the class mark, you can use either. It still gives you the same answer. So for the class mark here, what you do is 10.5 plus 20.5, you divide by 2. You plus them, divide by 2, then you get 15.5. So all these are your class mark and your class size. And notice that in this example, the size are not the same. You see, the first three, the size are the same, 10. Then we have size is 5. Then we have size is 15. So some question, they have the size not the same, okay? So you have to be careful, and there is a different way to solve it, which we call it as adjusted frequency, which I will explain as soon as we can cover the syllabus lah. Yeah? But any questions so far, class?
No.
All clear, yeah? So how about you, Calvin? All clear?
Yeah.
Okay. So this is another example. Now notice the difference between example number 1 and example number 2. What do you see are the difference? Anybody can tell me?
The symbol.
Yeah, one thing is the symbol, and another thing is, you see the value 10 is the same as this value. Same. So that means this data, it is from 5 to less than 10. So it could be that the value we have here is 9.9999 because it's simply less than 10. So the next value is 10 to less than 15. It could be 14.9999. Is that clear? So it's different with the data earlier. Here, there is a gap, 20 to 21. That means this is the kind of data which we call it as discrete data, because you can categorize it either in the first one or in the second one. Whereas this data, the next one, is continuous because we're talking about values that has decimal places. So when we have this kind of data, that means the value 10 is the same here also. They are the same. Then the class boundary, no need to have the 0.5. So we have 5 to 10. The next one, 10 to 15, 15 to 20, and 20 to 30. The class size, same thing. You just minus 10 minus 5, 15 minus 10, 20 minus 15, and 30 minus 20. And the class mark, just add them up and divide by 2, which gives you all these values. So I hope you see the difference between the example 1 and example 2. For this kind of data, we're talking about continuous kind of data. Remember, there's two types, right? Discrete and continuous. My spelling is all wrong. Well, anyway, this is continuous data, and the one previously is discrete. So you see, when there is a gap, 20 and 21, you need to put the class boundary with the 0.5. But when it is continuous, no need. Just use the same value. Is that clear?
Okay.
Clear. I hope you understand. No problem, huh? Okay. So with that, when that's clear, then we go on to how do you present graphically, which is using the histogram and frequency polygon. Yeah. So there are two graphical representation of frequency distribution. There's only two types we're going to focus on, which is the histogram and the frequency polygon. Yeah. And the first one is the frequency histogram. Then we have the relative frequency histogram. Then we have the percentage histogram. All three types of the histogram are covered in your tutorials. There are questions concerning these. So it is important for you guys to understand what does it differs. They are all basically the same. It's just that the calculation of relative and percentage are slightly different. Like relative, it's base per 100, and percentage you multiply base per 100. Yeah. So same thing, we have three types of polygon: frequency polygon, relative frequency polygon, and percentage polygon. So what is the difference? So you can see here we have the weights of 20 students in kilograms. And we have 60 to 62, whereby we have the class mark. The frequency also already obtained earlier, 3, 4, 5, 6, and 2. In fact, in the assessment later on, this table is already provided for you. No need to do the raw data where you have to categorize it somewhere. No, you will be given this table, frequency distribution table, ready for you. It's just that you need to know how to evaluate them. Okay, so we have the weight, class mark, and number of students. And all this, you can portray it in this, what we call as the frequency histogram. whereby you can see 59.5 to 62.5 is the value of 3. 62.5 to 65.5 to the value of 4, and 5 and 6 and 2. So this is what we call as a histogram. It's a frequency histogram because it's based on the frequency. And of course, here is the weight in kilograms. You can see the weight in kilograms here. Now, the frequency polygon, on the other hand, is in reference. Oops, I didn't show it here. When we talk about the frequency polygon, is identifying the midpoint on each point. You can see my pointer here is starting from here. The middle one, connect to the middle here as well. And each midpoint there, you connect with a straight line. So when you connect with a straight line, it will create a frequency polygon. Okay? Clear, class?
So the histogram is the rectangle thing.
Yes, correct. Yeah. So each one of these rectangle is representing the first category, second category, and so on.
Okay.
Yeah. Now remember, when you're doing the graph, yeah, the scale is not given to you, meaning you are the person who decide to draw the graph. I mean the size of your graph. But of course, the best graph is to draw it 1 A4 size, maximize the graph. Because when you maximize the graph, the accuracy of your answer is very good. Yeah, very clear cut. Yeah. So don't draw your graph very small, because once you want to read the answer, it's very difficult to read the answer. Yeah. So this is just showing you the histogram. I hope you know how to draw it. It is based on the class boundary. Here you have 59.5 to 62.5, and it's the value 3. So that's why we have here 59.5 to 62.5, and the height is 3. Now, when you draw it on graph paper, no need to shade it. Just leave it. Just draw the lines. No need to color it. Yeah, just leave it blank. Then we have then we have relative frequency. For any given class, to get the relative frequency is that the frequency of the class divided by sum of all frequency. So sum of all frequency in this example, same example, is 20, isn't it? So based on the frequency of each class, here is 3. 3 over 20, you'll get your relative frequency. But the percentage frequency is whatever relative frequency you obtain, you just times it with 100. So basically what we have are all these values. 3 over 20, you get 0.15. You times 100, you get 15. 4 over 20, you get 0.20. Times 100, you get 20. So notice here, if you add all this value for percentage, 15 plus 20 plus 25 plus 30 plus 10 will give you the value of 100. And relative frequency 0.15 plus 0.20, 0.25, and 0.30, and 0.10 will give you the value of 1. Okay? So sorry?
The relative frequency,
yes, is equal to 1.
Must
yes.
be in decimal form.
Correct. Yes.
Oh.
Well,
Okay.
if you want to put it in like a fraction form, it's still okay. It's still the same value, and when you add it all up, it should be 1.
Oh.
Yeah. For the frequency is the total. Total is 20, of course. But relative frequency, when you total it, it's equal to 1. Percentage would be 100. Okay. So of course, these are the values which you can. Do you have the relative frequency histogram and percentage histogram in your notes? Let me double check. Hold on. You have it in your notes, right? On page 11. Do you have it? Yeah, you have it. You can check it on your notes on page 11. The relative frequency drawing and the percentage drawing. And basically, when you look at it, let me go back to my slides. It's the same. It's the same as this representation. Yeah, it's just that the value here, the value on the x-axis and the x-axis is still the same, but the y-axis, it will be different. It will be stated here as a relative frequency or percentage lah. Yeah, you can see it in your notes. All right, I didn't show it here in my slides because I did ask you to refer to the histogram, relative frequency histogram and percentage histogram in your notes. Yeah, do refer to them. Again, let me repeat at this moment, it is unsure whether you'll be asked to draw the histogram as part of your assessment, because other subjects, other statistical subjects, drawing of graph is not encouraged because we're doing classes still online, right? So drawing graph is still a bit, how do you say, not encouraged for online assessment. But for the business students, yeah, the RAF and RBU students, they were asked to draw graph, if I'm not mistaken. Yeah. So, oh, I do have it here. Oh man, I thought I didn't show it here, but it's here. The relative frequency is the gram. This is the one, and you notice the y-axis. Do you see here? It's written as relative frequency. I thought I don't have it in my slides. Yeah. So you see the pattern is still the same. Pattern means the height of each of the bars, they are the same, but it's just the leveling of the relative frequency and the values here. You can see from 0 to, well, I put highest is 0.35. Actually, the highest is only at up to 0.3, isn't it? Yeah. And also the percentage histogram. You can see now it's in percentage. Yes. Is that clear?
Oh, yeah.
Okay. Kelvin, okay?
Yeah, we need to draw this graph in the exam or in the question.
Yeah, that's why I'm not so sure yet. I have to get confirmation from the course coordinator whether we need to. Maybe your assessment for coursework, yes, but then it might also be you will not be asked to draw the graph. You'll have to look at the graph given to you in the question and evaluate it. Meaning the graph is already prepared for you, the histogram already prepared to you, and you just have to evaluate it lah. Yeah, so it can be either way. But I will definitely ask from the course coordinator whether there would be a need for you to prepare graph paper or not for this subject. Okay? Right. So we have another example here. This is the weight of 35 objects. Okay, and measured to the nearest kg. And we are to draw a histogram to illustrate the data. So you can see here the frequency is already prepared. 6 to 9, 9 to 11, 12 to 17, 18 to 20, 21 to 29. You can see the class size is not the same. You can see here 3, 3. These are the same. Then suddenly 12 to 17, the size is 6. 3 again, and then 9. These are the frequency. So you can see here the class width or class boundaries, because here 6 to 8, that means 5.5 to 8.5. 9 to 11 is 8.5 to 11.5. 12 to 17 is 11.5 to 17.5, and so forth. So here, for those with the same size, 3, 3, and 3, which is the majority, isn't it? the frequency still the same. 4 to 4, 6 to 6, 3 to 3. Is that clear? Yes?
Okay.
Okay. However, for those with the size which is bigger, here it's 6, here is 9. What we need to do is to do what we call as adjusted frequency or standard frequency, because now the 3, which is the standard size, pay attention, 3 is the standard size, 10 is the frequency, and 6 is the size. So when you calculate it, it's 5. So now the height for this class is not 10 anymore, it becomes 5. Because when the width is bigger, doubled, the height would be reduced half also. Okay, but for this, look here, 21 to 29, the frequency is 12, but the width is 9. Yeah, so how do we calculate it? Based on this formula,
So just
3
3/9
3
times
over 9.
times 12.
3 times 12 divided by 9. And that would give you 4. So this is what you need to calculate. Yeah, in case when you encounter the frequency distribution given to you is not the same size. Like here, you got 6 and 9. They are not the same, whereby the common one is the size 3. The common one with the size 3, no change. But the ones with a different size, you have to do extra calculation such as this. And once you got that, you draw it on the graph paper. Well, this is the formula, okay? The standard, or what we also call it as adjusted frequency. The common class size, which our common class size in this example is 3, times with the frequency and divide by the class width. Yeah, class width accordingly. Like here is 6, here is 9. So from here, you can see the drawing of the standard frequency, the histogram to show the weight of 35 objects measured to the nearest kg. And you can see the labeling on the y-axis is standard or adjusted frequency. You can see 3, the first one, second one. Here, you can see there's a, what do you call that? A line separating these two batches, but actually it's not. And you can see it's only up to the level of 5. When you draw it, no need to draw the line in the middle. Yeah, same thing here. It's lowered to 4 now, but by right it was supposed to be 12. But because of the size is not the same, so you can see it's from 20.5 to 29.5. So that's why it's lowered and wider now. So this is the drawing of the histogram for this example. Is that clear?
Hey, wait. So I have to refer the after the calculation or the before.
The before, the after. That means we're referring to the standard frequency now, 4, 6, 5, 3, and 4.
Okay.
So instead of using 10, it becomes 5. Instead of using 12, it becomes 4 now.
Okay.
Yeah, so if you look at this graph, you can see it here. So you see it's 5 and it's 4. It's wider though. You see the color, it's this referred to one color. I couldn't remove the line in the middle. Yeah, so it's by right, you don't need to draw this green line in the middle in between this orange color. Yeah, it's showing you a shorter rectangle, but by right it's supposed to be 12, right? But because it's a wider 20.5 to 29.5, that's why it's only up to 4 only when we draw it on histogram. Okay. Okay, good. Right, so for unequal class size, this is an extra example. I don't think you have it in your in your notes, but just to show you, you see the class size 100, 100, 100 the same. Suddenly 200, 200. So if the frequency is 10, 18, 8, they are the same because the standard size is 100. But for the class that is doubled, you can see what happened here. Yeah, this is the common class size. What happened here is we times with 6 and times with 4, whereby 100 times 6 divided by 200, 100 times 4 divided by 200, and we get these values. Is that clear?
Okay.
Okay, so this is the formula actually. The 100 is depending on what is your class size. Here is so happen 100, makan. It's not a fixed value. It depends on your question also. Yeah, then times the frequency and divide by the class size. All right. So the graphical representation, this is just to show you how it looks like. You see it's wider here, 299.5 to 499.5, and from 499.5 to 699.5. So this is a histogram of sales of 46 branches of a company in 1 week. Yeah, so we call it as adjusted frequency, and the x-axis is the sales units. What time already? We only have 1 more minute. I just finished up the cumulative frequency. I think you remember cumulative frequency, whereby you have to total all the frequency of all the values that is less than the upper class boundary of each class. That means we keep on adding the frequency as we go to each category. Yeah. So we also have a cumulative relative frequency, whereby you find out cumulative frequency divided by sum of all frequency. And we also have cumulative percentage, which is cumulative relative frequency times 100. So just like similar to the histogram just now, histogram, we have the frequency, relative frequency and cumulative percentage, isn't it? So same thing with in cumulative frequency. Yeah. So if I'm using the same example, the frequency as given to you here. So when we want to derive the cumulative frequency, we start off with the lowest class boundary. You can see 60 here. So the lowest is 59.9. So that's why we start off with 59.5. That start off with 0. So at 62.5, we have 3 already. At 65.5, 3 plus 4, you get 7. 68.5, you add 3 plus 4 plus 5, you get 12. 71.5, you add 3, 4, 5, and 6, you get 18. And 74.5, you got 20. Hey, do you have class at 11, another lecturer?
At 11:30.
Oh, just give me a few more minutes, okay? So we have cumulative frequency here. So that's why you got 0, 3, 7, 12, and 18, and 20. So the value 20 is practically referring to the total of the frequency here. So if you add all the frequency, it still gives you the value of 20. Okay, and of course here will show us the cumulative relative frequency and cumulative percentage, all the values here. Oops, too fast. Yeah, so basically, how do I get 0.15? Because 3 over 20, you get 0.15. 7 over 20, you get 0.35. 12 over 20, 0.60. 18 over 20, and 20 over 20, you get 1. Cumulative percentage, you just times 100, and that gives you all this value. Any question?
No.
Okay, I think I stop here. I still have this one last slide. Yeah, is it one last slide? Yeah, more explanation. I can show it to you now. Can you give me just a bit of time?
Can.
Yeah, from this example, yeah, the total number of students that their weight were less than 67 kg. So you need to refer to your x-axis. 67 kg is somewhere here, because 65.5 to 68.5. So 67 kg is somewhere here, which you draw a straight line up until you reach the octave, and you draw horizontally, that would give you 9.3. So from the graph, 9.3 students were less than 67 kg. Approximately 9 students were less than 67 kg, because you cannot classify students as 9.3, isn't it? So we just take the value of 9. And then the second question, the value of x, if 20% of the students with the weight of x kg or more. So in this case, we're referring to, because 20 is the maximum, right? So 20% is basically referring to only 80%, start from the bottom. So 80% of 20 is giving us 16. So that's why we refer to 16. And when you draw from horizontally to vertically down, you get 70.2 kg as your solution. Okay, so you can see part A, we refer from the x-axis because it's concerning with the weight. And part B of the question, we're referring to the y-axis, the cumulative frequency, in order to determine what is the weight, what is the x lah. Yeah, so is that clear? Any question?
Okay.
Yeah.
No.
So what I'm going to do is I'm going to give the questions for tutorial for tomorrow's session using WhatsApp. So I'll see you tomorrow then.
Okay.
Okay. Thank you very much, everyone. Have a nice
Okay. Thank you.